In this video, we will demonstrate the Logic Error Hunter debugging capabilities and functionality, which helps users to investigate problems in the PLC program and rectify them. In order to do that and to debug a PLC program or particular test case that would be failing in a test suite execution, you have to open the PLC program, and after that open the test case in the PLC program and execute it to generate a execution trace and analyze the execution trace and signals in the PLC program and so on. So that's what we're gonna demonstrate next. So pretty much we open the PLC program, which seems to be failing on a particular test case, by executing the file open PLC program for testing command, which allows the user to select the PLC program file and opening it. So after opening the PLC program file, we need to check the two in order to generate debug information like PLC signal or tag trace information. We need in the options menu to check generate trace option, and in order to create breakpoints or break conditions and also to step the PLC program or cycle step the PLC program, we need to allow debug info in trace. If we don't want to debug by tracing and stepping the program or creating breakpoints, we don't have to allow debug info in trace option. Next, after these two options are checked, we have to open a test case. Let's assume we open a test case which has failed, and we have to execute it to see. Normally when the test case is failing, it would run till the end of the verification and it would generate a false result. So let's run the test case. So this test case seems to be passing because it generates in 15,028 scan cycles. It seems to be becoming true, which is actually meaning that the test case is passing, but we will pretend that it's not passing and we will try to debug it as if it's not passing. So pretty much in order to debug the test case, there are, as I mentioned already, two possible approaches. The first one is just to trace or trend PLC signals and see their behavior or trace their behavior by just specifying PLC signals. And let's, for instance, specify for trending the state machine. This is a state machine test, and let's trace the state machine state, for instance, here, and a couple of other signals, analogs and digitals, just to demonstrate what is happening. So let's trace this analog output from the state machine module and a couple of digital inputs from this module as well. So let's specify, for instance, this one, and so next, after we specify trace signals, in order to trend them, we need to execute the counter example to generate the trace information, and we will do that with this button here. So we start the execution runs to the end, and after that we can open the waveform viewer in which we can view the traced signals. So this is a standard off-the-shelf tool which is embedded in the Logic Error Hunter, and as we can see, all the signals that we wanted to trace are here. We select them all for tracing and put them in the trace pane. And just because it's by default it's showing in hex format. We want to show in decimal format. We have to convert, after which we can trace signals in the traceform viewer just by clamping to each change of state of any of the signals or whatever, but you can pretty much trace all the signals here and you can see how they behave. And you can see that the digital signals, which are controlled by digital input signals, which are controlled by the logic error hunter, are driven in a specific way here. But the step integer, which is the state of the state machine, goes from 1, 10 to 20 to 30 as it's seen, and that's what we would expect for the test case to pass. Another way of debugging a PLC program is really setting up breakpoints for it and then stepping through the code to see what the PLC program does and watch the highlighting in the PLC program in order to see what the signals in the PLC program are doing. So we do that. Setting a breakpoint or break condition is again done from this list of breakpoints, trace points dialog by right clicking on this icon here and then setting just a breakpoint, and the breakpoint would be just, let's say, step integer becomes equal to step 20. By the way, the states in this state machine increment always by 10, like the first one is 10, then 20, 30 and so on. So we set the break condition and then again execute the counter example and see what happens. So the execution is being started and the breakpoint which we set up has been hit in cycle 527. And actually the PLC program stops exactly on the next state after the breakpoint condition has been met. As you can see, actually this is this rank really transitions the state machine from state 10 to state 20, and that's what we actually want. We want to stop when the step integer becomes 20, so that's exactly the spot where it became 20, and from here on we can pretty much step the program and see the highlighting of signals in order to see what's going on with the signals and identify a potential problem in the PLC program. So to keep the execution point of the PLC program in focus, we just click that button and then do stepping in the counter example. And as you can see, it executes status, and signals that are on are highlighted in red. Those that are off are highlighted in black. For instance, this one is off, this one is on, this one is off as well. You can also execute in cycle step mode. It would cycle step forward, or you can run again the counter example, but it will break on the break condition again. So it hit again the break condition because the state is still 20, and it will hit pretty much on every single step of the PLC program because the break condition is still true. So pretty much that's all the debugging facilities in the Logic Error Hunter which would help you to debug a PLC program. There are of course a few more, like searching for tags in the PLC program or going to different tags in the PLC program, but these are rather just tedious details that you can get familiar with when you purchase the tool and read through the user manual.